So, today we are going to discuss on a new topic of differentiation, that is to find the derivative of a function in its parametric form. So, what is a parametric form? Now you know that whenever a function y is given in terms of x, we call it as y is a function of f of x, isn't it? So normally we used to find the derivative of the function where y is equal to f of x, and you find what? Dy by dx. Find the derivative of y with respect to x. Now here in parametric form, x and y are given in with expression of a parameter in it. So I take fx as a function in t and y as a function in t. Okay, whenever a function is given in terms of t, you could find only the derivative with respect to t, isn't it? So here, when I find the derivative of x with respect to t, I will write it as dx by dt. So dx by dt is equal to what? Our f dash t, right? And again I find dy by dt. So because y is another function of t. So dy by dt, I get it as g dash t. Now what are we trying to find? It is dy by dx. Now to obtain dy by dx, what will I do? Dy by dt divided by dx by dt. Okay, so this is the formula for finding dy by dx when both x and y are given in its parametric form. Now, what is the parameter here? Here in this function, t is the parameter. Okay, so here in the function, t is the parameter. I will give you an example here. Another question where x is equal to a cos theta and y is equal to a sin theta. A very simple example. Okay, now what is the parameter here in this my question? In this question of mine, the parameter is theta. Okay, so I find first dx by d theta. What is dx by d theta? A into minus of sin theta. Now what is dy by d theta? Because when I find the derivative, I can find the derivative only with respect to theta. So dy by d theta is a cos theta. Now I come to the conclusion. What is dy by dx is equal to dy by d theta divided by dx by d theta. That is a cos theta by minus a sin theta, which is equal to minus of cot theta. Am I clear? So here what did I do? I found the derivative of x with respect to the parameter here, which is theta, and again I found the derivative of y with respect to theta, which is the parameter here. And finally dy by dx is equal to dy by d theta divided by dx by d theta. Here in my theory part I have taken with respect to theta. The parameter was theta. Here in the example I have taken it as theta. Here it is t. Sorry, here it is t. Here it is theta. Am I clear? We will discuss more questions. Okay. Now let's see another question. If x is equal to a into theta minus sin theta and y is equal to a into 1 plus cos theta, find dy by dx. So here x is equal to a into theta minus sin theta. And what is y? Y is equal to a into 1 plus cos theta. So now dx by d theta, where parameter is what? Theta. So first function a into constant, a is a constant, let that be there. 1 minus sin theta derivative cos theta. Right? Now, which is, now I find dy by d theta. Dy by d theta is what? A into minus of sin theta. Am I clear? Now, what is dy by dx here? Dy by dx is equal to minus a sin theta. If you want, you can write the formula what dy by d theta divided by dx by d theta. So here a minus a sin theta into 1 minus cos theta. Am I clear? So here a and a cancel. Minus of sin theta, I could write it as 2 sin theta by 2 cos theta by 2. Half angle formula by 1 minus cos theta, I will write it as what? 2 sin square theta by 2. 2 sin square theta by 2. 2 and 2 cancel. One of the sign also cancels. Minus of cos theta by 2 by sin theta by 2. What is that? Which is negative of cot theta by 2. Am I clear? That is dy by dx. Okay. Next we come to the next question. If x is equal to, the next question is, if x is equal to root of a sin inverse of x and y is equal to root of a cos inverse of x, show that dy by dx is equal to minus y by x. So let's see. I simply multiply x into y. This is a board question actually. So what is xy? Xy is root of a raised to sin inverse of x into a raised to cos inverse of x, or root of a sin inverse of x into root of a cos inverse of x. When I merge it, I get it like this. So this is root of a raised to sin inverse of x plus cos inverse of x. Now let me ask you, what is sin inverse of x plus cos inverse of x? You know that it is pi by 2. So it is root of a raised to pi by 2. Now a raised to pi by 2 is a constant. Okay. A raised to pi by 2. Pi by 2 is a constant. A is also a constant. A raised to pi by 2 root of it is a constant. Now I apply the product rule here. X into y dash plus y into derivative of x is what? 1. So this is equal to 0. So what is y dash? Y dash is equal to, when y comes this side, minus y. X comes here, denominator minus y by x. Am I clear? These are very simple questions. Okay. Now we come to the next question. If x is equal to a into cos t plus log of tan t by 2 and y is equal to a sin t, find dy by dx. Again, this is a parametric form. So here dx by dt is equal to a into a is a constant, derivative of cos t is minus of sin t plus 1 by tan of t by 2. That is log x is 1 by x. So log of tan t by 2 is 1 by tan t by 2. Derivative of tan is what? Sec square t by 2. Tan x is sec squared x. That of t by 2 is what? 1 by 2. 2x is 2. Derivative of 2x is 2. This is 1 by 2t. That is 1 by 2. Okay. So this is the derivative. Now here I'll just go for a simplification. A into minus of sin t plus 1 by tan t by 2. I can write it as cos t by 2 by sin t by 2. Am I clear? By 1 by cos square t by 2, and there is a 1 by 2 here. Now one of the cos cancels. Okay, so this gives me a into minus of sin t plus 1 by 2 sin t by 2 cos t by 2. Now 2 sin x cos x is sin 2x. So here I have it as minus of sin t plus 1 by 2 sin t by 2 cos t by 2 is what? Sin of 2t by 2. That is sin t. Okay. Now this is equal to a into this. I bring it this side. What will I get? 1 minus sin square t by sin t. I multiply, cross multiply sin square t by sin t. This is equal to a into cos square t by sin t. Am I clear? A into cos square. 1 minus sin square t is cos square t. A into cos square t by sin t. Now dy by dt. What is dy by dt? That is a into cos t. Right? A into cos t. So dy by dx is equal to a cos t divided by a into cos square t by sin t. Now a and a cancel. This is equal to cos t into sin t by cos square t. One of the cos get cancelled, and sin t by cos t, what is the value? Tan t. Am I clear? Okay. Let's move on to the next question. Now let's move on to the next question, where x is equal to theta plus 1 by theta raised to the power of a, and y is equal to a raised to theta plus 1 by theta. Okay, now here I will take log, but here I needn't take log because it is raised to the power of a constant value. So what is dx by d theta? Parameter here is theta. That is a into theta plus 1 by theta raised to the power of a minus 1 into 1 minus 1 by theta square. Am I clear? Derivative. This is x raised to the power of 2. X raised to the power of 2 is 2x raised to the power of 2 minus 1. So x raised to the power of a minus 1. That of theta plus 1 by theta is theta derivative 1. 1 by theta derivative minus of 1 by theta square. So this is equal to, so this is what I get for dx by d theta. Now I have, now I have y is equal to a raised to theta plus 1 by theta. Now before I proceed, let me ask, what is d by dx of a raised to the power of x? We know that the derivative of a raised to the power of x is a raised to the power of x log a. Okay. This is the derivative of a raised to the power of x. Now here dy by d theta is equal to a raised to the power of x, a raised to the power of theta plus 1 by theta into log a. Okay, that of theta plus 1 by theta is what? 1 minus 1 by theta the square. So dy by dx is equal to a raised to the power of theta plus 1 by theta into log a into 1 minus 1 by theta square, that is dy by d theta, divided by dx by d theta, that is a into theta plus 1 by theta the whole raised to the power of a minus 1 into 1 minus 1 by theta square. Now this and this get cancelled. What do we get? A raised to the power of theta plus 1 by theta into log a by a into theta plus 1 by theta raised to the power of a minus 1. So that is the derivative of that is the derivative, that is dy by dx. Taking dx by d theta, dy by d theta, and finally dy by dx. Am I clear? Go through this once again, children. Now let's see another question. X is given by sin cube t by root of cos 2t. Y is equal to cos cube t by root of cos 2t. You are asked to find dy by dx. Okay. So here dx by d theta, dt. T is the parameter. So denominator into derivative of the numerator, that is 3 sin square t into cos t, minus numerator into derivative of denominator 1 by 2 root of cos 2t. That of cos 2t is minus of sin 2t. That of 2t is 2. So 2 and 2 cancels. Divided by root of cos 2t the square. So root and square nullifies. I cross multiply. What do I get? 3 into cos 2t into sin square t into cos t plus sin cube t into sin 2t, the whole divided by, here root and square nullifies and I get a cos 2t. This root is coming to the denominator. So what do I get? Cos 2t raised to the power of 3 by 2. Am I clear? There is a root there. There is power 1 plus 1 by 2, that is 3 by 2. Okay. Now I find dy by dt. What is dy by dt? It is root of cos 2t into 3 cos square t into minus of sin t. Derivative of cos t is minus of sin t minus root of, cos cube t into 1 by 2 root of cos 2t. That of cos 2t is minus of sin 2t into 2 by root of cos 2t the square. When I root and square nullifies, this 2 and 2 cancels. Again, when I cross multiply, what do I get? I get this as cos 2t 3 times. This 3 I brought it to the front. Cos square t into sin t plus cos cube t into sin 2t divided by cos 2t the whole raised to the power of 3 by 2. Am I clear so far? Okay, now what is dy by dx? So dy by dx, if you look at the denominators are the same. So I need to write the numerators only. I have a negative value here. I just skipped on that. Okay. So minus of 3 cos 2t into cos square t into sin t plus cos cube t into sin 2t divided by, what do I have? This expression 3 cos 2t sin square t cos t plus sin cube t into sin 2t. Am I clear? So now I have this again. This is the value of dy by dx. Now I am going to simplify this into its simplest form. So I have minus of 3 cos 2t into cos square t into sin t plus cos cube t. I will write sin 2t as 2 sin t cos t. Fine. The whole divided by 3 cos 2t into sin square t into cos t plus sin cube t into 2 sin t cos t. Now substituting for, I have substituted for 2 sin 2t as 2 sin t cos t, isn't it? Now I will take sin t cos t common out. What do I get? Sin t cos t, when taken out, I get this as minus 3 cos 2t into cos t plus 2 cos cube t, right? Sin t cos t has moved out, divided by sin t cos t from the denominator. What do I get? 3 cos 2t into sin t plus 2 sin cube t, right? 2 sin cube t. Now this and this cancels. Now here for this cos 2t I will substitute for 2 cos square t minus 1, and for this cos 2t I will substitute 1 minus 2 sin square t and then simplify on it. So I'll get this as minus 3 into 2 cos square t minus 1 into cos t plus 2 cos cube t divided by 3 into 1 minus 2 sin square t into sin t plus 2 sin cube t. Clear? This is equal to minus 6 cos cube t. This cos comes inside. Plus 3 times cos t plus 2 cos cube t divided by 3 sin t minus 6 sin cube t plus 2 sin cube t. So what do I get? And this is equal to 3 cos t minus 4 cos cube t, right? 3 cos t minus 4 cos cube t divided by 3 sin t, and this 3 sin t remains as it is, minus 4 sin cube t. Now from the numerator I may take a negative common out. That gives me 4 cos cube t minus 3 cos t divided by 3 sin t minus 4 sin cube t. This is equal to what? Minus of, this is cos 3t divided by sin 3t, which is equal to minus of cot 3t. This is the simplest form of it, minus of cot 3t. Hope you understood this and you can follow this. Some values of trigonometric ratios I have used here. So do try to understand this once again, go through it once again and try.